Hello, now we are going to discuss about what are the qualities of a good design. And we are looking from the point of view of reducing the propagation of changes, okay, and increasing the locality of changes. And basically, if you look at these in all the literature, you will find two words, cohesion and coupling. And they are strongly related properties. And so I'm going basically to explain to you what they mean. And then what I'll do next is go through some design patterns that you already know and analyze them from the point of view of cohesion and coupling and see if that works. So if by looking at them through this filter, you actually conclude it's their qualities as the way you learn when you learn them. Okay, let's go then. So first thing, let's talk about eye cohesion. So the idea of eye cohesion is that each module has a single responsibility, which means that all the code that is inside the module is related with the same responsibility, which means that you are looking for increasing the locality of change in the sense that if all the code is related with the responsibility, it means that if you are going to change that is related with that responsibility. So it's this idea that basically all the context is inside the same module. So it's very helpful when you try to change something and in your brain you just look around and the context is there. So it helps you to reasoning and to reason, and so it reduces the cost of change. Okay, so eye cohesion is one quality, and the other one is low coupling. So basically, by low coupling, it means that it should reduce the dependencies between modules. So we are trying to reduce the change, the propagation of change. So what is the idea is that if there are low coupling between two module A to module B, means that most of the times when you change module A, you do not need to change module B. So I'm gonna show you an example so that you can understand a bit the properties. So if, let's look at first at this case, if there's a change that needs to be applied to this model and we change it inside, okay, if it does not propagate, then I do not need to change this module, right? But what is interesting is that this property is asymmetric because I may have a change in this module that propagates to change that model. So propagation, basically the coupling is asymmetric. It means that you cannot say that what is the coupling between A and B, but you say what is the coupling of A in relation to B. Okay, so it means that if A is strongly coupled with B, means that most of the times when you change B, you need to change A. Okay, and the symmetric is not necessarily true. You may change A a lot of times without changing B. So let's look at some patterns and reason about these patterns in terms of eye cohesion and low coupling. Okay. So let's see design patterns. The first one is the command design pattern. If you remember, so the idea of the command design pattern is objectify an action. So now instead a function or an action is inside an object, and this has a lot of qualities because basically you can you can deal with it as an object, so you can inherit from it, you can just delay it, you can resubmit it, so that's the advantage of command. So if you remember, you have the command, which is an abstract class that provides an abstract interface, and then I have the concrete commands that contain the concrete code, okay? And the invoker has low coupling with the command Why? Because it just uses this abstraction here. And then the abstraction is implemented in each concrete command. So what is the advantage here is that it's easy to add new concrete commands or even change the instance of a command without having impact on the invoker, which means that the concrete command is, and the command is loosely coupled with the invoker. So basically the invoker does not need to know about what is the internals of the command. But the client creates concrete commands. So someone that really, the part of the code that creates the commands depends on the concrete command, which makes sense. Okay? So I have strongly coupling here, right? And low coupling here. And now let's think in terms of cohesion. What is interesting is that you have high cohesion inside the concrete command, because related with the command, you can have do, and for instance, do and undo operations. So all the operations are in the same place. They have the same responsibility. So if you need to change something about that concrete command, we only need to look inside the concrete command class. Okay? So that was the analysis in terms of coupling and cohesion. Another well-known pattern is the composite design pattern. Oh, and the idea basic is in the composite design pattern, you define a recursive structure. And the big advantage is you can add new elements to this structure, and more importantly, you can change them during runtime. So during runtime, you can just change this tree, and the operations continue to occur in this tree according to the order of the tree. So basically, you send invoke one element, and then this element can invoke the operation in all the elements in its subtree, right? So let's look at it. So if you remember, I have a client and I have a component, okay, which is an abstract entity, and then you have two types of subclasses, which are the leaf and the composite. And the composite contains several components. So you see here the dynamic part, in the sense that, well, when I just invoke an operation here, you can propagate the operation to all the elements there, and you can basically add and remove components. So you can change the tree during runtime. So let's think in terms of coupling. Well, in terms of coupling, the client is decoupled from the component. Why? Basically, he only needs to know the operation. He does not need to know the structure. So this is, for instance, the example. If you are in an interface, and the interface is implemented as the user interface is implemented as a composite, you have an operation there that receives a click. So when you click with the mouse, and this is propagated in this structure so that the correct element answers to this operation. Okay? And another thing that is interesting is the coupling that I will talk later in terms of the importance of abstractions, is that this decouple between client to component is stronger if these operation be more abstract. In a lot of cases, this operation is implemented as a command. Okay? So actually then you can have a command there, which makes it more abstract, because what you do is an execute. Okay? An execute. Good. And then you have cohesion. Where do you have cohesion? Because all the elements in a particular leaf, for instance, are related with the functionality of this entity. So all the operations that are implemented here are in the same place. So if you think in the interface, and you think about a particular widget in the interface, if you want to understand what is the behavior of this widget, we'll only need to look inside it, and we'll see all the operations that it provides. Okay? Good. So I think this is the most relevant parts about cohesion and coupling. Oh, of course, and another thing, these makes very easy to extend because of this abstraction here. You can create, because of this low coupling, you can extend with new types of leaves and new types of components as far as they preserve the abstract interface. Okay, so the coupling is of an interface, of an abstraction. This is always what occurs. Finally, I will address another design pattern, which is the state pattern. And the state pattern, basically what you have, so the idea of a state pattern is when your code starts to have a lot of methods that have a lot of if then else, if then else, if then else, because of different states. Look, what you do is that you're going to decouple these function or this method into a set of objects and put the particular behavior for a particular state, because each if corresponds to a state in each own object, okay, or in each own class, and you call this class the state. So it's here. So what you think, the way to look at it, if handle is a particular method, handle is actually two parts of an if the method is there. Okay, so what happens here? What happens is that you get cohesion in the sense that if you want to look at what is the state, what is the behavior of this object in a particular state, all the code is there. So the cohesion is related with the state. But any design decision is a trade-off. Now, if you want to understand what is the behavior of a particular operation or a particular method, you need to look at the different states. Okay, when should you decide to go one way or another? Depends on the type of changes and the propagation of changes. So if most of the time you do a change that is a change of a concrete state, you like this way, because then by changing a state, all the methods, all the behavior of the state is in the same place. If you want to change a particular operation, then you need to go to different states and change the operation. So it means that it has strong, high cohesion from the point of view of the state, and not so good cohesion from the point of view of the method or the function. Okay, but this is object-oriented programming, not functional programming. Good. So, and what about coupling? Well, the context is decoupled from the state. In the sense, you can create new states, and this basically is independent of the context. Why? Because the context, the only need to do is to interact with an abstraction that is in the interface of the state. Good? Okay. And as an exercise, you can basically look in terms of coupling and cohesion for all the patterns you have learned. Okay, and always think about this, that any design, well, as a software engineering in general, everything depends, and every design decision is something that you say, okay, what is important is this aspect, and now other aspects will not be considered, like I explained to you about this, if I look from the state point of view or from the functionality point of view. Okay, enjoy.